Jai Hind, my dear children. Today we are going to study variation of resistivity with temperature. The resistivity of a material depends on temperature. The relation between temperature and resistivity is given by rho equals rho 0 into 1 plus alpha T minus T0, where rho and rho 0 are resistivities at temperatures T and T0, and alpha is temperature coefficient of resistivity. The same formula is applicable for resistance. R equals R reference into 1 plus alpha T minus T reference, where alpha is temperature coefficient of resistance. Here R reference is the resistance at any reference temperature, which can be 0 degrees Celsius or room temperature. Temperature dependence of resistivity. We have resistivity of any material is given by the formula rho equals m divided by n e square 2, where rho represents the resistivity, m represents the mass of the charge carriers, n represents the number density, which is number of charge carriers or electrons per unit volume. E represents the charge and tau represents the relaxation time, that is the average time between two successive collisions. Now, for metals, what happens as temperature increases? So, for metals, as temperature, T represents the temperature, temperature increases. As temperature increases, what happens? The velocity or the speed of the free electrons, the thermal speed of the free electrons increases. Okay, so as temperature increases, speed of free electrons increases. Free electrons increases. Okay, so as speed increases, what happens? The collision rate, collision increases. Okay, so collision increases. So as collision increases, what happens to the time between two successive collision? So it undergoes collision frequently, no? So what happens to the relaxation time? Relaxation time decreases, right? Relaxation time decreases. Relaxation time is tau. Tau decreases. So as tau decreases, according to the formula, as tau decreases, what happens to resistivity? Resistivity increases. That is the reason. So for metals, as temperature increases, the thermal speed of the free electrons increases, the collision increases, amplitude of collision increases. So what happens? Relaxation time or time between successive collision decreases, and hence resistivity increases. Here it shows the variation of resistivity with temperature for metals. It shows that as temperature increases, resistivity also increases. This is the graph for copper. Resistivity of a metal increases with the increase in temperature, and hence metals have positive temperature coefficient of resistivity. Now, for semiconductors and insulators, we have resistivities given by rho equals m divided by n e square 2. Here also, as temperature increases, what happens to the speed of free electrons? The thermal speed of the free electrons increases. Relaxation time decreases. But in the case of semiconductor, as temperature increases, n, what is n? The number density, number of free charge carriers per unit volume. That increases exponentially. That means as temperature increases, more and more free electrons are produced there, and holes are also produced in the case of semiconductors. So as temperature increases, more amount of charge carriers are produced, and hence what happens to n? N increases exponentially. So as temperature increases, there also collision increases, and there also relaxation time decreases. In addition to that, the number density, number of electrons per unit volume, or the number of charge carriers per unit volume increases exponentially. Okay, so increase in n is more prominent than decrease in tau. Increase in n is more stronger, prominent means stronger than decrease in tau. Increase in n is more prominent than decrease in tau. So according to the formula, n increases exponentially, tau decreases, and hence what happens to resistivity? Resistivity decreases. That is the reason. So in the case of semiconductor and insulators, once more, as temperature increases, the speed of the charge carriers increases, collision increases, relaxation time decreases, but number of charge carriers increases exponentially, and hence increase in N is more prominent than decrease in tau. As the result, what happens to resistivity? Resistivity decreases in the case of semiconductors and insulators for increase in temperature. Temperature dependence on resistivity for semiconductors is given, which shows that as temperature increases, resistivity decreases, and hence semiconductors have negative temperature coefficient of resistivity. Now for alloys. Alloys like nichrome, manganese and constantan exhibit weak dependence of resistivity with temperature. Here for nichrome, as temperature increases, what happens to resistivity? It increases, but it increases very slightly. Hence, manganese and constantan are used for making wire-bound resistors, example in rheostat. Thus, in metals, as temperature increases, resistivity increases. In semiconductors, as temperature increases, resistivity decreases. And in alloys, resistivity is very large but have weak temperature dependence. Okay, children? Thank you.